Let's practice a little bit with graphing a linear equation. This topic is found in Chapter 3 of your ALEKS Integrated textbook. I'm sure all of you have vague memories of doing this in the past. Generally speaking, when we're trying to graph linear equations, a very popular thing to do is play the y equals mx plus b card, because this is the most famous version of the equation of a line, and everybody probably remembers that if you can rearrange your equation into this form, the value of m is your slope and the value of b is your y-intercept. So in this problem, we will play the y equals mx plus b card by rearranging our equation to get it to look like this, and we'll pick out those values and draw using those. And then in the next example, I'll show you a slightly different method of figuring out the positioning of a line, which frankly I think is a little bit easier. But this is popular, so what the heck, we'll go with it. So I'm going to start manipulating my equation to leave the term with the y on the left-hand side and the term with the x moved over to the right-hand side. Just like with generic solutions to equations, I'm in charge of this expression. I am free to do anything I want to it just about, as long as I do it properly, meaning I have to do the same thing to the left side and the right side. I would like to see this term with the x disappear from the left-hand side, and so I can subtract 1/2 x from the left-hand side to make that happen. That means I also have to subtract a 1/2 x on the right-hand side to maintain the equality. So I am, in my head, subtracting 1/2 x from the left-hand side. That will leave the 3y alone on the left-hand side. This 6 is still sitting over there on the right, joined by now the minus 1/2 x, which is included on that right-hand side. So it's just like we took this term, just swoop, moved it over there by subtracting it from both sides. I put the subtraction of that term to the left of the 6, again, just because I'm keeping in mind my y equals mx plus b card, and I usually want the variable x term to the left of the constant. Alrighty, and now to isolate y, I want to divide both sides by 3. So I'm just making a little note there that I'm about to divide by 3, or equivalently multiply by 1/3, and maybe that's a good idea here because I'm going to be doing fractions of fractions there on the right-hand side. So maybe it's useful to see the division by 3 represented as a multiplication by 1/3. There we go, better focus. So I end up with a y on the left-hand side. And then over here, 1/3 times negative 1/2 is negative 1/6 x. And then 1/3 times plus 6, 6 over 3, that's a 2. And so, one more time, showing that y equals mx plus b card, I now see the slope and the y-intercept for this particular item. For this particular line, I will have a slope of negative 1/6, which means my line is going downhill, and a y-intercept of 2. And so now I can place this line appropriately. It's very faint, but I'm going to consider every little tick mark on this graph paper to be half a unit. And so the y-intercept of 2, there's half 1, 1.5, 2. There's a y-coordinate of 2. And then to count off a slope of negative 1/6, that means I'm going downhill, and I'm going down by 1 for every 6 I move horizontally. So remember, rise over run. So downhill by 1 unit for every 1, 2, 3, 4. This is going to go off the page because this is a very, very gentle slope. So the other, if I go down by 1 and over by 6, my second point's going to end up actually off the page over there. So I'm just going to kind of estimate what this is going to look like. Something like that. A y-intercept of 2 and a very, very gentle downhill negative slope of negative 1/6.